Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video guys, I'll be tackling the second question from the mid-year examination which was written in the province of KwaZulu-Natal in the year of 2024. Please do expect a total number of 10 videos since the question paper had 10 questions in total. And please guys do take this seriously. I strongly believe that this will give you an edge whenever you write your mid-year exam, your preliminary exam, and also, and most importantly rather, your final examination. So please do share the video to your peers so that they may have the same edge as you. Okay, we are given a quadratic sequence. They want us to determine the next two terms of our quadratic sequence. Okay, remember that guys, a quadratic sequence is a sequence that has two differences. The first difference is arithmetic, whereas the second difference is common. Okay, so I'll simply have negative 5, 12, and 27. Okay, so this will give me, for me to find the first difference, and I need to say 12 minus 5, that's 17, and then 27 minus 12, 27 minus 12, this will give me 15. Yeah? And then for me to find the second difference, I need to say 15 minus 17, this will give me negative 2. I know that this is constant. That's negative 2. That's negative 2. Are you together? Okay, so for me to find the next terms of the first difference, I just need to add the second difference. Now, look at this. I said 17 plus negative 2, I'll simply get 15. 15 plus negative 2, this will give us 13. 13 plus negative 2, this will give us 11. Okay, but we were not asked to find the values of the first difference. We were asked to find the next two terms of our sequence. So I'll simply say 27 plus 13, that's 40. And then 40 plus 11, that's just 51. So the next two terms are just 40 and 51, right? Then I'm supposed to determine the expression for the general formula of our quadratic sequence. The expression for the general formula, guys, we just need to know the values of both rather a, b, and c, right? Why? Because the nth term is equal to an squared plus bn plus c. If I know the values of a, b, and c, I can simply write down the expression of my general formula. I know that 2a is equal to the second difference, and then 3a plus b is equal to the first term of the first difference, and then I know that a plus b plus c is equal to the first term of the sequence. So 2a is equal to negative 2. That means a is basically equal to negative 1. Okay, and then 3a plus b is just equal to 17. Then 3 multiplied by negative 1 plus b is 17. Therefore, b is just equal to 17 plus 3, that's 20. Then let's go and find the value of c. I know that a plus b plus c should be equal to negative 5. A is negative 1, b, that's 20. I don't know the value of c. So I simply have the value of c to be equal to negative 5 minus 19. That's basically negative 24. Negative 5 minus 19. That's negative 4, right? So I now know the values of a, b, and c. I can go and substitute them over there. So therefore, the nth term is just negative 1n squared plus 20n minus 24. So my nth term, the nth term is basically negative n squared plus 20n minus 24. Okay, and then all I have to do now, I'm being asked which terms of the quadratic sequence have the value of 51. Which terms of the quadratic sequence have the value of 51? Already we know that the fifth term, 1, 2, 3, 4, 5. Yeah, the fifth term is equal to 51, right? So whenever, guys, I'm solving, I'm expecting to find one of the values of n to be equal to 5. Okay, let's just do so. The nth term is 51. Tn is equal to negative n squared plus 20n minus 24. I want to find the value of n if and only if Tn is equal to 51. If and only if Tn is equal to 51 plus 20n minus 24. Then all I have to do is to make sure that I bring these on the other side. Now the n squared will be positive, the 20n will be negative, and then I'll simply have 51 plus 24. This will simply give me 75. So I'm looking for the factors of 75 that when I add will give me 20. I'm thinking of 20 and, I mean rather 15 and 5. 15 times 5, yeah. That's 15 and 5. The sign here is positive, so I'll have negative and negative there, taking the sign of the middle term. That means n is 15 and n is 5. Indeed, guys, we did say that the fifth term should be equal to 51, right? So the terms T5 is equal to 51, and then T15 is also equal to 51. Okay, now we are told to calculate the value of this sigma expression over here, né? Okay, so this will simply mean I'll simply have T3 plus T4 plus T5 T6 T7 T8 plus T9 plus T10. Ne? I'll just substituting the n value starting from this one, and then I'll keep on incrementing. Are you together? So we'll say T3, T4 until T10 because there's 10 there at the top. And then I'll subtract these ones. Ne? Let me just use a blue color. That will basically be minus T11 minus T12 minus, and I'm subtracting these guys because I have a negative sign there. Ne? So it's minus T13 minus T14 minus T15 T16 and T17. Okay, remember that, guys, we have a quadratic sequence. A quadratic sequence, guys, you can take it as a quadratic function, which simply means that we do have axes of symmetry. Are you together? If we were to draw a quadratic function for this sequence, we would have something like this over there, and then we would have the axis of symmetry there, the x value at the turning point. Are you together? And I know that, okay, the y value over there is the same as the y value over here. Why? Because they are symmetrical to the turning point, right? The y value over there will be equal to the y value over there, even though I have two different x values. Are you together? The y value over there will be equal to the y value over there. Same thing applies in here, guys. Ne? You can punch your calculator since you have your general formula over there. Ne? You can verify this by punching your calculator. The third term of your sequence will be equal to the 17th term of your sequence. Ne? So the third term of our sequence is 27. That means also have 27 over there. So I have 27 minus 27. They will just subtract one another. And then I'll have 40 minus 40, 51 minus 51. These guys will go on and on. These terms will just subtract one another over and over again until I'm left with the 10th term alone, because it does not have its corresponding value. So it simply means that this expression, the difference in this sigma notation, is just equal to the 10th term of our sequence. And our 10th term is basically negative 10 squared plus 20 times 10 minus 24. And then this will simply be equal to negative 10 squared plus 20 times 10 minus 24. This is just equal to 76. So the difference between these two sigma values is just 76. I really hope that, guys, You gained a lot here. So just stay tuned and wait for more videos. And please guys, do help us grow the channel by just subscribing.